Assalamualaikum warahmatullahi wabarakatuh. I am Abdul Asyraf and I'm the only person in my group and my project is signature verification. Okay, so a little bit about the function. So what it does is it takes two images of signatures, compare the two, and returns the status. So if it's the same or if it's a different signature. Alright. So how it works is it takes two images, a ref and compare. The ref is the reference image and compare is the image you want to compare. So B would the compare would be the signature that you want to test, and ref is your the signature that you are sure is the correct one. Right. So it'll take the two images A and B here and make them into grayscale images, gray A and gray B, and then it takes the size of it. So why we take the size of the image is we want to resize either one or both of the images into the exact same size. So what it does is it'll compare the heights and the widths of the images. So if one image is higher, it has higher height than the other, it will make the image slightly less tall, so they'll have the same height and the same width. And then it'll plot the two images, and then we have SSIM here, which is structural similarity. So what this does is it compares two images and returns the similarity value along with the map, which is the image of the two images overlaid on top of each other. So this function takes two arguments. The first argument is the image you want to test, and the second argument is the reference image. So in our case, gray A would be the reference and gray B would be the one that we want to test. And this function will also output the overlaid image with the value of the similarity as the title. Okay, over here we have another check to see to like categorize the signatures as either valid, invalid, somewhat similar. So what we have here is if the value is above 0.95, because the SSIM value would be from 0 to 1, with 0 being very different, no similarity at all, and 1 being, well, basically the same image. So if it's more than 0.95, it's valid. If it's more than 0.5, but it will be less than 0.95 because that's how the if-else cascade works. It will return somewhat similar. So we need to check other ways other than just signatures. And else, which means if it's less than 0.5, they are very different, possible forgeries. Right, so let's test this. I already have here. Okay, so by comparing these two, it will output the two images that I have here. So right, so what we have here is the two images and the result of the comparison. So it says here it's valid. So and we can see in the images themselves with just visually we can confirm that they are somewhat similar. And yeah, so and then the value is 0.96, so this is somewhat correct. And then we can do another comparison. So this takes two signatures that are obviously different, but yeah, according to the algorithm, it says it still has a value of 0.90066, but then it returns somewhat similar because we have the threshold set at 0.95. So the problem with this method is that it is not very accurate because it doesn't use any machine learning method. It doesn't use any neural networks, however, because I want to keep this function simple and very light, because this only takes 50 lines of code, and all it does is it compares the two images and see if it's similar or not similar. It doesn't check if it's if the number of loops, the size of it, the stroke length, stroke weight is similar or not. So it doesn't do any of that. It just takes the two images, compare them, and returns a value of similarity. So that's the weakness and strength, I suppose, because it's very light, but it's not very accurate. Alright, that is all. Thank you.